So, while Jeff was talking about the different environmental conditions and how they affected the sensors, I focused more on how these affected the different odors and how specifically temperature and pressure would affect how the odor diffused throughout my team's aquarium assay. So I tried to use, or have been using thermodynamic equations to, with butyric acid, benzyl acetate, trimethylene, and R-limonene, which were the 4 odors that we really focused on, and discovered how they vaporize within the aquarium, and I've been trying to really get an idea of how they move by using their diffusion coefficients. So I didn't really want to bog it all down with a bunch of equations, but these were 3 of the ones that I used primarily. First, I used this estimation of the diffusion coefficient up there to see how they moved once they had gone from their liquid phase to the gas phase. And then I used this along with their vapor pressure to try to get an estimate of how they would move as a volume, which is their diffusion flux through the aquarium. So diffusion flux is actually the amount of the substance, either their polarity or volume, over their length squared time. So to find this value, I used this simple equation, J equals negative D, and the is the actual concentration. So the goal of all this was to determine if the level of attraction of the flies was actually because of preference through their olfactory system, or if it was actually just the chemicals moving more quickly than each other. So I used liquid equilibrium BLE properties to discover exactly how fast they move from their liquid phase to the gas phase, and then, as I mentioned before, their diffusion gradient, how fast that was moving. So the problem with my project has been that I found limited or contradictory research on outdoor chemicals. They've not been very widely researched in terms of their thermodynamic properties, so I was finding different values for them that were opposing. So I ran into this problem a lot, and I wasted a lot of time. But very recently, I found this piece of software designed to do Chemtron, and it's actually a very complex program which has a huge database of chemicals and different flow sheet parameters that I was able to utilize to find more accurate.
Excuse me. Let's stay out there. Okay.